Hi, everybody. This is Kamal. I'm co-founder at AccelerateAI. As part of this series, we are going to talk to you about data visualization with Python using Plotly library. This is a very, very powerful library in terms of collaboration, in terms of interactive charting. We have already discussed about Seaborn and Matplotlib in our previous videos. I'll share you the link to those on the comment section. You can go and check those. Now, in this video, we'll focus on Plotly. Our agenda today, we are going to focus on motivation about it, various packages in Python. Then we'll go deep dive into Plotly, and then we'll also focus on the summary or the key takeaways. Now, obviously, this is something we have talked about in the past as well. The motivation is primarily what is the business need or objective when we talk about data visualization or exploratory data analysis. There has to be an objective. If the data distribution is what we are looking at, then we are going to look into these type of charts. Then if we're going to talk about composition, part to whole composition kind of thing, then we're going to talk about waffle chart, pie chart, and so on. And of course, for the correlationship and relationship kind of thing, then we're going to talk about scatter plot, bubble plot, and so on. Comparison, if the need is comparison, then of course, these type of charts can be used. Now, when we look at various packages in Python, this part of this particular series, we are going to cover some of the important ones. And as part of this session, we are going to focus on Plotly. When we look at Python visualization landscape, Plotly is actually part of the JavaScript library. It's related to that. It's a graphing library using D3 and stack.gl. It helps create interactive and publication quality charts. What we have seen in Matplotlib and Seaborn is Seaborn, of course, is abstract layer on top of Matplotlib. Plotly, you can also think as an abstraction on top of that, but it's more as part of a JavaScript library. So it uses D3 and stack.gl. There are three key interfaces as part of the API that it looks into. One is an object-oriented interface. Second is the high-level interface, which is similar to Seaborn, but it's named as Plotly Express. We will see what that is. And then third is imperative interface that allows us to specify our plot using JSON-like data structures. Okay. And some of the usage, if we look at in Plotly, we can use AI, machine learning kind of charts. That's possible, like regression. We can do classification. We can get ROC values. We can get PCA. All of these things can be done. Then Plotly Express that we spoke about, which is a high-level interface like Seaborn, is in Dash. Dash is the best way to build analytical apps in Python using Plotly figures. So if we quickly look into it, some of the fundamental charts we can create with Plotly. We will not go deeper into it. We'll focus on some of the animations as part of this video. But to give you a reflection of what are the charts can be created as part of fundamental charts, you can look at any of these. We can look at setting the font title, the legends, the x's, multiple x's, subplots, different type of display of figures, and so on. Similarly, statistical charts also can be drawn in a very seamless manner. Pictorially, it's also very appealing aesthetic-wise. The box plots, histograms, list plots, scatter plot, all of these can be created as part of this. This is also another one, the AI ML related chart options. We can create a regression. We'll see an example of that. KNN classification, your receiver operating characteristic or ROC and precision recall curves kind of charts, those can be represented easily. There are PCA visualizations, those can be done. And of course, we can have AI/ML apps with Dash on the images and all as well. There are various map options. This is also very handy because we can use the choropleth maps, the lines on the map box, different areas filled with different structures and then denominations. Those we can look at it. Bubble map can also be created, lines on maps, and we can control it. That's more important aspect of it. We also have Jupyter widgets interaction. We can use some of these like click events, like some of the, figure widgets kind of thing. We will see that how we can interactively change the chart options dynamically, and end user purpose standpoint, it's more intuitive. So let's quickly get on to the demo. So this is the notebook, Jupyter notebook. When we look at data visualization with Plotly, some of the libraries that we want to import, one of them is very important, which is plotly.express. And that's a TERS consistent high-level API used for creating figures. This particular module, which is typically imported as PX, import plotly.express as PX. That's the convention. It contains functions that can create entire figures at once and is referred to as Plotly Express or PX. It is built in as part of the Plotly library and is recommended starting point from for most of the creating most of figures within Plotly, right? And the other one is plotly.graph_objects, typically denoted as GO. And the figures created, manipulated, and rendered by the Plotly Python library are represented by tree-like data structures, which are automatically serialized to JSON kind of formats for rendering the plotly.js JavaScript library, because since it's part of the JavaScript library. So these trees are composed of named nodes called attributes. And then with their structure defined by the plotly.js schema, which is available in a machine readable form. And the plotly.graph_objects or GO that we are referring it here is essentially, it contains automatically generated hierarchy of Python classes, which represented some of the non-leaf nodes in this figure. And these refer to the instances of these classes, right? And we will also use IPY widgets, which is also known as Jupyter widgets or simply widgets. And then these are all interactive HTML widgets for your Jupyter notebooks and the IPython kernel that we are using it here. So you also have other, as per the usage of your use case, import datetime, NumPy, pandas, we can do. Then we are taking an example of dataset, which is New York City flights dataset. Our objective here is we'll be making an application to take a look at the delays from all flights out of New York City in the year 2013. So that's the objective that we're trying to answer from this data set. And here, when we kind of look into the data set, you would have year, month, day, a lot of these variables. You have carrier here, that like the airlines code, which is United Airlines or American Airlines or JetBlue, P6 or Delta, and so on. And also other things like origin, from where within the New York City that it is originating from. Is it from Newark, which is EWR, or LaGuardia, LGA, or John F. Kennedy? Those things are also mentioned it here. So what we are going to, for our intention of this objective, is we'll be making an application to take a look at the delays of all flights out of NYC as an origin, and then it has got 3 airports. So we'll look by that in this particular one year, which is 2013 that we are analyzing up. So let's get all set of airlines so that we can type the right things into the search box later. So that's where we are doing .unique to get a unique list of airline codes. Then for the interactive charts purpose, what we'll do is we will assign the widgets that we are going to be using in our application. In general, all these widgets will be used to filter the data set, and thus we will be able to visualize those. So what we are doing is, as part of this, if you look at month, we are saying widgets.int slider, and then we are kind of giving the min, max, step, increment, and all that stuff. So this is essentially nothing but your month representation from 1 to 12, January to December. That's one. Then you have a date checkbox. We can check it and uncheck as well. And then we also have something called as text box, which is widgets.drop down kind of a text box, where we are going to capture the airline drop down, because we have seen from New York City, there are 3 different codes as part of that. And that's what we will see in the output. Then we also have the airport code there, right? So sorry, this one is the airline dropdown, which is like Delta or JetBlue or United Airlines and so on. And then this one is the New York City specific three airport codes like Newark, LaGuardia, and John F. Kennedy. So what we are doing here is we are assigning an empty figure widget to with two traces. We are saying Geo is something that we have created here as plotly.graph underscore objects. That is our Geo. Okay, and what we are saying here is geo.histogram, and we are giving the x value as arrival delay in trace one. In trace two, we are saying departure delay. Okay, and there's with some amount of opacity, and then we are saying geo.figure widget, and then of course we're trying to put the layout with some of the text as the title and so on. Right now, let's now write a function to that will handle the input from the widgets when we enter as an end user, and then alter the state of the graph accordingly. So we are using a validate function there. We are using a response where we wanted to take the input months, origin, and based on that, it will show the arrival delay, departure delay in the g.batch underscore update. That's where we are doing all this. So if you run this and then call the widgets.hbox and then widgets.vbox, then you'll be able to see this particular output which is coming up. And this is very interactive. For example, origin airport, if I'm going to select EWR, then it's going to give EWR. Let me run this again. Right. So if we're going to use LGA and change the airline, then it automatically gets changed, right? Let me run this again. We'll quickly run it again to see this, so that we don't get that cache related issues. Right. So here, if we change this, so this is again, as you would see, EWR, which is Newark. And these are all your departure delays. These are your arrival delays. If I change this to John F. Kennedy, then of course, for the same airline, there is a different representation. Okay. And you can change that to, month 2, which is for February, month 4 for April, and so on, month 6 for June, and so on. If we change this to, let's say, United Airlines, you have got a different chart. So look at some of the interactiveness in the chart. You have the origin airport of the data from the column that we are getting the values from. The airline, the month, all of these we are dynamically changing, giving the user the ability to change and view this particular histogram appropriately, right? Then there is something called as click events that we will see, where we can use and update points in the chart using a click or callback. So for this purpose, we are using kind of a scatter chart, and what we will see is you have got a scatter plot with the sample numbers in the x and y axis of the markers that we have randomly taking from 0 to 100 numbers in x and y axis, and we are trying to see here. If you want to click on it, it'll change the color and increase the size of it, right? It'll the size and the color is something that we're changing based on the click, right? If you click on this, that again changes to green. If you click on this will change. If you click on this will change. And again, if you want to reset and run it again, you are back to the chart again, where the x and y values are represented and shown also when we point it. We click on it, that gets changed. We click on it, that gets changed. So this is kind of a click event that we are able to achieve in this particular chart, right? Then getting on to the AI ML kind of chart, where we are going to talk about linear regression plotting, and in two ways. One is using your ordinary list square OLS with the plotly.express, which is PX. And in this use case, it shows how to use the PX trendline parameter to train a simple OLS for predicting tips of waiters that they will receive based on the value of the total bill. So this is a standard data set which comes as part of it, and then we are using it. If you look at it, it's so simple. We are taking px.data.tips into our data frame. And then in the figure, we are saying px, which is plotly express, dot scatter. And then we are saying the data frame, then we are giving the x-axis, which is your total bill, and your y-axis, which is tip. We are providing the opacity, we are giving the trend line, and the rule of the method is here OLS. So it will show regression based on OLS, and then the color of the trend line. The moment we execute this, then as you would see what happens, you would have all of these points and then this particular thing. Now, the moment you click on any point in the line, you would be able to see the equation tip equal to the entire equation of the regression that it's coming up, R square values, all of these things are demonstrated here. So, tip is, y-axis, total base in your x-axis, and then you have this regression that you're able to do using OLS. Now, same thing, we can do it using scikit-learn as well. Now, in scikit-learn, what we need to do is same kind of thing, regression, but we are saying we are taking the help of sklearn.linear model, importing the linear regression from that. And then we are using that linear regression to model.fit using that particular tip database. And if you would see, we are going to achieve the same thing here, just that in the way the regression fits here is slightly different compared to what we have seen here in the OLS type. So both are two different approaches, but it gives the same result pretty much. Then very interesting, more animations. If we look at several plotly express functions, they support creation of animated figures. We can use through animation underscore frame or animation underscore group as the arguments. As you would see here, we have used an example of animated scatter plot using this plotly express px, and we are using the Gapminder data where we are saying px.scatter because it's going to show the scatter plot kind of information. And then on one side, we have the GDP of various countries and continents for that matter, grouped up into, and then the life expectancy here. So if you look at it, you have the continent, Asia, Europe, Africa, Americas, Oceania, all of these, and the life expectancy of this. And then what we also want to do is want to kind of orchestrate it from year 1952 to 2007. So this is obviously for 1952. Now, how the dynamism that you'll get or the interactivity that you'll get in the graph, if you click on this, then as you would see, it goes from 1952 to 2007. If you look at it again, I'll run this, starts from 1952, 77, 82, 87, 92, and all the way up to 2007. And here, if you see, this is Japan with highest life expectancy within Asia. This is the last two bubbles because of the population, China and India, and then so on. For Europe also, for Africa, for Americas and Oceania, right? So beautiful presentation of dynamically how we can control it. One thing that we have to be careful is the range of X and range of Y. We have to make sure it is within that particular range because the dynamism of this bubbles, the way it behaves, it has to be within that range. Otherwise, it will go out of the bounds, right? And then one more example, if we go to on the population increase by continent. This is again a simple one. It uses the same Gapminder data, but we are trying to show here by continent, what is the population, how it is growing over a period of time. Same 1952 to 2007, same data set that we have taken. And then if we execute this, then you can see how Asia, Europe, Africa, America, Oceania, how they're, again, if you want to run this, it'll start from 1952 and goes all the way to 2007, then the increasing portion of it, right? So that's about it. We wanted to quickly show you some of these demonstration of beautiful charts, which is dynamic, which can be collaborated. And that was the objective that we wanted to show. Then we'll quickly move on to the key takeaways. If you look at it, like other charts of Matplotlib and Seaborn, we have pretty much similar set of takeaways. One additional thing that we would say is Plotly is more powerful and more interactive, that we have seen more dynamic. It gives user that actions for that rich API that it uses as part of the JavaScript library under that flavor. And from a collaboration perspective, it's very, very important. And that's where it's much more powerful from this perspective compared to Matplotlib and Seaborn, right? Other than that, remaining all aspects are pretty much similar and same for each and every aspects of the libraries that we use. The purpose, the audience, looking at the captions, the do not trust the defaults. You have to use it effectively, then use the color effectively, avoid charging. Those all pretty much the same, like Matplotlib and Seaborn as well. So that's about it. Thank you so much. I hope you have enjoyed looking at this and you'll learn something. If you're not familiar with it, you can try by going through some of these libraries, and they are very powerful, and you can use it in your own Jupyter notebook, taking some example of data sets. You can leave any comments, feedback on the description, on the comments below. I would request you to subscribe our channel, Accelerate AI on YouTube, and also the LinkedIn you can follow. And then if you have any questions, any suggestions, please do not feel free, hesitate to send it across to our Gmail ID mentioned here. Thank you so much.